Here's 6-29. It says, for each recursively defined sequence below, write the first few terms, then use the terms to write an explicit equation. Well, when something is recursively defined, what the recursive means is that it's telling you what to do to find the next term. So n plus 1 is the next term. So in other words, if 17 is the first term, then the second term would be, 1 plus 1 or n plus 1. And then all you'd have to do is take 17 minus 3. So in other words, let's show you. Here's how I always set mine up. I always write the term numbers. The reason I'm including the 0 term, well, I'll explain that in a minute, but I got the first term, the second term, the third term, the fourth term. So they tell me a sub 1, which means the first term, is 17. And then they say a sub n plus 1 is just a sub n minus 3. What that means is the next term is just the term before it minus 3. So basically I can just keep minusing 3. So 17 minus 3, that's 14 minus 3. So that's where these numbers come from. And then it wants an explicit equation. So an explicit equation, what they want is, if it's arithmetic, let's say it's arithmetic, if it's adding or subtracting each time, it's arithmetic, then it's going to be linear. It's going to look like y equals mx plus b. Okay, if it's geometric, like it's multiplying, then it's going to look like y equals a times b to the x. Okay, this one, I see that it's always adding -3 each time. So I know that my explicit equation is going to look linear, like this one. So I just left it in y equals mx plus b because I'm thinking you're familiar with that because you've done a lot of work with it. Now if I were just trying to find the equation of a line that had these points 0, 20, 1, 17, then the growth factor would be -3, and I would plug it in for m, right? Well, do it. And then the starting point would be b, so I have to go backwards. So I ask myself, what minus 3 gave 17? So basically I'm adding 3. And I got 20. So plug that in, and then I just change it around. So now this notation tells anyone who's reading it that it's not a function, it's a sequence. So this thing would be continuous. This would look like a line, right? This would look like some kind of line like that. This thing would look discrete, where it would have just little dots. Well, sorry, it's supposed to look straight. It's supposed to look linear. I hope that made sense. So knowing what I just said, the next problem, they give you the first term is 20. So I wrote the 0 term, the 1 term, the 2, 3, 4, 5. So I stuck my 20 in there, and then they say n plus 1, which you can think of that as just saying the next term, you take half of a sub n. So basically I'm taking half of the term before it to get the next term. So half of 20 is 10, half of 10 is 5, and so on. And then why do I want to find the 0 term? Well, because I hope that this is a little bit familiar to you. I hope you've seen exponentials before. This is your basic exponential function. So this is what it's going to look like if you have a geometric sequence. Geometric means it's multiplying each time. See the difference? This one up here was adding -3 each time. This one's multiplying by a half. You could say it's dividing, or you could say it's multiplying by a half. So since this one's multiplying every time, I want it in the form of y equals a times b to the x. And if you don't remember this from when you studied exponentials, the a is the starting point, the starting number, and the b is the growth factor. So we know our growth factor is a half, so it's actually getting smaller. So you plug that in. How did I get this number? Well, I just asked myself, if the first term is 20 and it's half of the term before it, what does that term have to be? It'd have to be 40. You can also think of it as just go backwards, multiply by 2. Anyway, so I plugged them in, and then this thing right here is the function, but this is the sequence. Okay, so this is the answer they want. The only difference between the function and the sequence is they use a sub n and n instead of y and x.